Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Okay, so today I'm going to give a lecture on a topic 4. Okay, so I have highlight that in the topic 4 we will learn two things. Okay, first is analysis of frame. So from that we will analyze of frame, and we will produce the bending moment, shear force and axial force. So actually we have done on that by looking on a few examples. Okay, so in the second part of this topic we will learn on the visual methods in a frame. Okay, so as a brief, actually the visual method of a frame, okay, the equations is exactly similar to the beam. Okay, so if you look on the topic 2, okay, on the visual method of the beam, so we have seen these two equations. Okay, so which is the equation for displacement and the equation for the rotation. Okay, so the equation for displacement and the rotation is seems equal, basically similar, but then it differs when on the visual diagram. Okay, so when you deal with this equation, you need to apply 1 unit load, and if you deal with this equation of rotation, you need to apply 1 unit moment. Okay, so the parameter consists is in this equation is a small m and capital M, and the flexural rigidity is specifically referred to the E and I. Okay, for the modulus of elasticity and the moment of inertia respectively. Okay, so the small m can be obtained from the visual diagram. Meanwhile, for the capital M, you could to find the equation to find in a actual diagram. Okay, so in the conclusion, the equation is still remain the same. You need to apply this equation again in the frame. Okay, so let's return to the slide in the topic 4. Okay, so I'm going to give some demonstration on how we can apply this visual method in the frame. Okay, so without further ado, let's look on the example 4. Okay, so if you look on these examples, we have a cantilever beam. Okay, actually we can consider this as a frame structure because it is consists of a horizontal and vertical element. Okay, and based on the examples, you need to determine the horizontal displacement of a point C of the beam. Okay, so which is this point. Okay, so and okay, as usual, when you deal with the visual work method, you need to have a two diagram, the real diagram and the visual diagram. Okay, so in the real diagram, you just copy down the diagram from the equations without changing anything. Meanwhile, for the visual diagram, you need to apply 1 unit load, since the equation is about to determine the horizontal displacement of point C. So you can see that here in the solution, 1 unit load applied at the point C to the left. But if you want to apply it to the right, it doesn't matter. Okay, it's not an issue. Okay, so based on this free body diagram, in the real and visual diagram, you need to find out the equation of moment, and you need to use a method of section, okay, to cut the member. So based on this real diagram, you have 3 numbers of cut section. So this is the first, second, and third. Okay, so similarly for the visuals, you have first, second, and third. Okay, so and you need to indicate the x distance in order to get the equation of moment. Okay, for example, here for the first cut section, which is a 0 to 4 D to C, so we will consider the x from D. Okay, for the second member, the x will be considered from the C, and for the third member, we will consider the x is from B. So in the example, actually we can skip to calculate the direction at A because our x are from D, C, and B. Okay, so not from A. Okay, so if you consider x from A, you need to get the direction value prior to get the equation of moment. Okay, so move to the next slide on the solution. Okay, so this since we have a 3 numbers of cut section, and you can see that they have a 3 free body diagram. Okay, so this is the first diagram for the first cut section. Okay, so this slide is a solution for moment based on the actual diagram. Okay, so and by considering the x from the free end, okay, which is point D. Okay, so and this is internal forces, considering all these external load and the internal moment, so you get the moment equal to negative 15x. Okay, so this for the second range, and the x is measured from C. Okay, so this is a free body diagram, and based on this diagram you have a 15 kilonewton load and the internal moment, so this gives me moment equal to negative 16 kilonewton meter. Okay, so and for the last diagram where x at which the range is 0 to 8, so x is measured from B, okay, from D, and based on this free body diagram, the equation of moment is equal to 15x minus 60. Okay, so and you can proceed to get the equation of moment for virtual diagram. Okay, so if you look on this solution, only two range. Okay, so and suppose we should to have a three numbers of cut section, and we should to have a three numbers of moment equation. Why only two equation available in the solution here? Okay, because if you look on the original diagram in the virtual diagram here, okay, so actually at the first range, which is a 0 to 4, so D to C, so there is no load, and this will result 0 moment value, or there is no equation in this range. So actually the solution skip this on this part, but in the real situation you could to indicate in the in your answer script. Okay, but okay, so I hope that you can understand why this range is not available in the solution. Okay, so let's return on the page that we have stopped there. Okay, so this is equation of moment. Okay, for the second range. The first range that it's not shown in the slide. Okay, because it will produce a 0 moment. And here in the second range we have mx equal to negative x. At the third range we have mx equal to negative 5. Okay, so if you realize all the x must be x distance must be measured from the same position for both of the diagram. Okay, so if you consider x from C for the actual, you need to treat the same thing for the virtual. Okay. Okay, so once you have obtained all the equation, you may to tabulate all the equation in table. So based on this table, you can see that they have 3 columns. So first is the limit, okay, or the range. Second is the equation for moment for the actual diagram, and the third column is the equation of moment based on the virtual diagram. And you can see that here is the moment for the virtual diagram. For the first limit is 0, which is not shown in the solution. Okay, so by using the equation of a virtual method that we have utilized in the bin, okay, so previously in the previous topic, okay, so and since we have 3 numbers of limits, so you need to have 3 numbers of term in the equation. Okay, so you just substitute all the equation of moment, okay, based on the limit, which is 0 to 4, 0 to 5, and 0 to 8 according to the limit in the table. Okay, so simplified, okay, all the equations, and finally you can see that you get the delta C equal to 0.025 meter. Okay, we got the positive value, meaning that the actual direction of displacement for this frame is parallel to our initial assumption of direction, okay, which is to the left. If you got negative value, so the actual displacement of frame is opposite from our assumption. Okay, so I have mentioned about this condition many times. Okay, so that's all for example 4. So we will continue the lecture in example 5. sorry, example 5. Okay, so later on, okay, so we take a break for 5 minutes.